years ago, I think.
Yeah.
Yeah.
When Rengie brought in a bunch of equipment and showed us how to use those things. When we first put this part of the program together, we were kind of, I don't know how many of you remember in November or October, November, you couldn't see a lot around here because the air was quite thick. So air quality was really an issue. And we thought that you guys might be interested in something about indoor air quality. We've changed the topic a little bit, but it's absolutely relevant to what you were just considering, and that is taking a look at how to make adequate ventilation in buildings. So, Rengie?
Thank you for having me. So the topic are relevant, talking about ventilation. It's still about indoor air quality to a little extent. If you don't have good ventilation, you don't have good indoor air quality. So that's the connection. Today I'm going to share with you some projects we do in schools, in homes, and also sometimes in a research lab to prove why ventilation is so important. This is our group. We're the indoor environment group. We do ventilation research, air cleaning research, and a whole slew of other things. Jenny mentioned that the wildfire in California. So some of you may have heard of air sensors. So you can now go out and buy some $200 air sensors. So the question is, are those things any good? So we can get into that, but not today. If you're interested in that, let me know. And I'd like to share with you some material after today. This is us. Brett's up there. We are a small group. We do laboratory research, field research. We have a laboratory, so we run, when we would be in indoor air quality, we go out and measure, bring it to the lab. We can do a lot of the analysis in the lab. When we were doing home research, we think cooking is the source of emission inside a home. So if you use a gas stove, it can emit particles, NO2. So we have a lab setting where we study that. We also have, working with facility here, we have something that we can test airflow measurement system, like how accurate they are. I'm not talking about a whole lot of these, but these are some of our capability. And when you get asked a question about indoor air quality, this is a really good resource that our group maintain. It's paid for by US EPA. We update it really frequently. So if there's a building ventilation question, like how does it affect indoor air quality, go there, take a look. There's a lot of information that's useful and relevant that I can't cover today, but it's a really good resource. So building ventilation. Our group does a lot of research looking at building ventilation because it affects indoor air quality, it affects people, it affects energy use, comfort, and so on. Today I'm going to talk about two recent projects that we were involved in, one in schools. We're working with UC Davis, looking at classrooms that just replaced the system. We wanted to know if those new retrofitted systems are working. And then another project working in homes. So new California homes since maybe about 5 years ago, they're all required to have mechanical ventilations. So we want to know what kind of system get put in. Are they working? Do people know how to use it? And what's indoor air quality is like? So when we talk about ventilation, it goes back to ASHRAE, set the standard. A lot of you are probably familiar with the around 8 or 7 liters per second per person. That's what's required. And then as different types of buildings will have different per floor area requirement and so on. But that's a basic requirement. And if you dig back into how ASHRAE came up into this number, it's all about how people feel about the space. That number was derived when we put people in a laboratory setting and then we provide them with ventilation. What's the level where people find indoor air quality being pretty good? So it's as acceptability test. Since then, the California Energy Commission has funded us to look at the building ventilation standard again. What if you were to consider something beyond just how people feel about the indoor air quality? What about we consider something about, for example, the chronic health exposure to all the chemicals that's in this room? How would we change the building ventilation standard if we were concerned about that? And what if we are concerned about space, not just acceptability, but how does it support productivity? If people need more ventilation to be productive, should we change the ventilation rate to something what ASHRAE requires now? So this is a project that we did a few years ago. we consider beyond what current standard is asking for, and go beyond that and think about in schools, if we want to support children in learning environment, what's the ventilation rate that's needed? And then work environment, if we want people to be more productive, what's the ventilation rate that's required? There are a series of research that we did, but this is an interesting study I want to talk about today. This is a study where we look at how ventilation can support decision making, so support work environment. It's a laboratory study, so we asked a lot of our subjects are recruited from campus. We put people in a room, and we provide different ventilation rate and test how they perform. This kind of explain the setup. And we're interested in this question of what are we ventilating for? Are we ventilating for the people? Are we ventilating to get rid of the VOC in the air? So with that question in mind, we designed this study where we separate out the emission that's generated from people and the emission that's generated from a room. So we put all the furniture and building surface in a room, and we can separately control the amount of air that we pump from that room to the people. Separately, we control the amount of ventilation we supply to the people. And by this unique study design, we're able to test what are we really ventilating for. Is it for the people, for the surface area, or what is it? And so we put our subjects in a room, and in order to test work performance, it used to be a lot of these tests are based on typing error, so we ask people to type and see if they make mistakes, but that doesn't really mimic today's work. Like when we work, we do higher level thinking, so that's a very important of when we designed the study. We don't want to test typing error or addition error. I mean, people don't do math anymore. So what's more important is to kind of mimic that the higher level thinking that's needed to support more relevant work that happens in office these days. So we collaborated with SUNY, the Upstate University in New York, try to come up with a test that can evaluate higher level thinking when people work. So this, and I'll go talk about the test in a little bit. So there's 4 test cases. We are able to independently vary the indoor air concentration in a room of the pollutants that people emit from lows and high, and also from the office emissions, just based on the setup that I talk about. So you can see that in condition 2, which is when we have high emission from people, because we tune down the ventilation rate supplied per person, after 3 hours, we have elevated CO2 concentrations to show that that's what happened. And on the bottom, this is the total VOC emitted that we measured. And you may be interested to see why 2 and 4 both have somewhat elevated TVOC. That's because number 2, when we don't supply a lot of ventilation to a room, people bring in some VOC with them. With these mostly students from campus, they brought their backpack, their laptop, their working, their clothing, the shampoo that they used the day before. So even people had some VOC emissions. And number 4 is purely from the material that is mostly from the material that we brought in. So you can see how we can independently vary these conditions. And at the same time, test how people work. So the test that we used is called the Strategic Management Simulation Test. I've never played it, but I was told it was like a Sim City type test. So you're a mayor of a city, there will be some crisis that happen, and you're supposed to figure it out and provide for your city. So depending on how you respond, how quickly you respond, how many things you do or not do, or how many things you missed or not missed, it's able to rate you on a 9 level of competence. It's some of it based on your speed of response, so if something happened to respond to it, to the really highly complex thinking. So did you have a strategy to deal with something? So this test has been used on pilots, has been used on various professionals. So there's some baseline data that we can compare. And within this, our test, our subjects didn't know what the 1, 2, 3, 4 cases they were. They just show up, they do a test, they rest, take lunch break, they come back and do the test again. So we are able to, some subjects were exposed to higher concentration in the morning, a lower concentration in the afternoon, and they're blind to it. So they're just doing this test. And there's some learning component to it. So I think the test would, when they analyze the data, they account for that factor. So our results are really, our design really try to address all the confounding factor that can happen. So what did we find, right? These are summary results judging on the 9 level of competence that we rate our subjects. We supply ventilation at the current rate, which is at the 8 liter per second per person. And when we also tested a lower ventilation rate at 2 liter per second per person. You can see that when we lower the ventilation rate, indeed we see that people perform worse on almost all the 9 areas of competency that we evaluate them at. And similarly, when subjects are exposed to lower ventilation rates applied on a per floor area level, and in this case, they're exposed to more pollutants from building surfaces, from furniture, they also perform worse. And they're completely blind to the situation. It's showing that ventilation really have an effect on people's performance. So some take-home message is based on this test that we did in the laboratory, and other research group, we can summarize it from what other people have done, come to a similar conclusion, which is ventilation is really important. If you don't have adequate ventilation, people are not going to perform at the same level as they had enough ventilation. And we dig the data in a little bit further, and we think the per person ventilation rate has a slightly stronger effect than the per floor area. So it's a bioeffluent that is affecting people. And that study results sometimes varies from study to study, so just want to mention that. But people are sometimes not able to tell about ventilation rate. So doing all these tests, we give people a survey. You rate about the indoor air quality. People are not able to tell whether they are at a higher or lower ventilation rate. So this points to we rely on the building manager really to be able to detect whether there's enough ventilation. People are not able to tell. Like temperature, people are able to tell, but ventilation rates, people are not able to tell. So as part of this body of research that was sponsored by the California Energy Commission, we also did a few other studies I'm not about to share today, but we did an interesting study in retail stores. Ventilation in retail stores, there we are likely ventilating for the stuff that is inside retail store. One outcome that was a little surprising was in a grocery store. We see a lot of cooking happening. So even though they have the kitchen ventilation, we still see cooking emission in grocery store being very, very strong signal. And then down to, I mentioned about, there's an interesting study we did. This is on respiratory illness absence. So we look at schools in 160 classrooms in California. We're able to see that classrooms that don't have enough ventilation have higher illness absence rates. So more kids getting sick in classrooms that don't have enough ventilation. So another important point to show that ventilation is important. So switching gear to a classroom study, this is an ongoing research study sponsored by the California Energy Commission. We're working with UC Davis with this. And you may have, if some of you are from California, a few years ago, there was Prop 39 got passed, so a lot of schools got some money to do energy efficiency upgrades. Some of them goes to ventilation, HVAC system upgrade. A lot of it goes to lighting and other aspect of it. So the state were interested in knowing, with a recent package, ventilation rate in classroom meeting standard. Traditionally, classroom are the one environment where there's a lot of under-ventilation happening because there's just a lot of kids. So the requirement for a classroom is about 450 CFM. It's a lot of CFM for a small space, and a lot of times it just doesn't quite hit that level. So we visited about 104 classrooms, 12 schools, and we're still able to find about 2/3 of classroom had CO2 levels that are exceeding what we expected. So we're like, well, we can't now blame all equipment, so what's happening? Now, take a step back. I want to point out a literature review that we did, and this is one that we did in school to point out why we care about this problem in classrooms so much, because it's tied to student performance, it's tied to illness absence, it's tied to health effects. The review study that we did, we look at not only our research, but other research that people have done here in the US, in Europe, internationally. It's a really strong correlation. When the classroom don't have ventilation, we see student performance suffered. And some of these are done based on looking at test scores. So you contact the district, look at the test score, you're able to correlate classrooms that don't have enough ventilation, accounting for other confounders that you expect to affect test scores, such as socioeconomic factor. You still see a correlation between ventilation and student performance. Sometimes these are intervention studies. So a researcher will go in, look at classrooms that don't have enough ventilation, adjust it, and then look at the before and after, how students perform. And they also see an effect that you improve the condition and students perform better. There's a question here.
Is there a level at which the degradation of performance sort of was evident?
We think you should definitely meet standard. We think there's, if the ventilation standard were to go up a little bit, we think that's benefit there. But for a classroom, meeting standard is the minimum. We think classrooms should meet standard. Yeah. But unless the standard currently is 450 CFM, which is a lot already, pushing that higher, we think that's benefit in that. I can tell you what the upper limit is. Is it 20 liter per minute or 20 liter per second per person? Right now it's 7. So it can go higher. When we look at studies that look at students' health, so asthma symptoms, asthma is a common symptom among school children, again, see association between ventilation and students' health. This was a study that I mentioned earlier, where we look at illness absence, so we're able to contact the school district, get the attendance data, and correlate with 2 years of CO2 data that we measured, and able to look at a correlation between the illness absence that the school district report and the ventilation rate, accounting for the demographics that are co-founding factors. So right now, I'd like to mention, that's where we are at. The Title 24 in California is the ventilation standard. It's around 7 liters per second per person. For the state average, or the 160 classroom that we were at, it's a lot lower. So definitely, we would like to see more classroom meeting standard. Got a question here?
You're doing a study on schools, and I remember hearing a report about schools being primarily located next to freeways, especially here in California, and the CO2 level next to freeways was significantly higher. Is that a big factor in your choice of these 28 schools of proximity to?
I don't think the CO2 level outdoors near freeway will be a little bit higher, but it's not enough to influence the ventilation rate estimate that we did based on the CO2. But school being close to freeway, the more important things to think about is particles emitted from a diesel. You can think of diesel exhaust, just one that's emitted. So it's very important to use good filters. That's one that we're pushing, that currently the MERV 8 should probably bumped up in Southern California. I think you're at MERV 13 if you're school near the freeway, so that's a really good suggestion for school near freeways. As part of the study, we try to show the states the economics benefits. Meeting the standard means you need to provide more outside air, meaning you need to, this classroom will need more heating and cooling. It's going to cost some money to the school district. But look, on the other side, a sick kid means a caregiver missing work. The amount of money that is in the cost-benefit analysis really outweigh if you improve school conditions so the kids are there to do the learning. So back to the project that started this part of the talk. So it's a project that we're working with UC Davis. is the Western Cooling and Efficiency Center that we're working with. They visited all 104 classrooms, and the question is, what went wrong? Like, why did these schools have new system, are still not having enough ventilation? So at each step of the way, they saw something going wrong. The design and equipment selection wasn't done quite right. We saw classrooms that purchased equipment that's meant for offices. So these are the temporary office, probably meant for an occupancy of about 10 people in the size of a classroom instead of 30 children. So that's one reason. Installation, sorry.
These are all the upgrades funded by Prop 39?
Part of it are supported by Prop 39. Installation, a lot of it is very important for the school district for like-to-like replacement so that the facility guys know how to use and how to maintain it. But even though equipment look exactly the same, once it's there, the wires don't quite fit, and we see the job's not getting done, so the contractor just walk away because it doesn't quite fit. The commission and acceptance tests supposed to be in California, so they're all supposed to be signed and checked, but there's definitely something that's missing there. And maintenance and operation, still the dirty filter's not getting changed, and we think that's a factor. The ventilation equipment type. So the 104 classrooms include some rooftop units, some BART units, so those are the through-the-wall units, and in both cases, we've seen something not done right. We've seen a lot of classroom economizers still continue to see problems with those, the control setting not right, or the wiring not right, and then we've seen some energy recovery ventilator. Installation being a big problem, we think it's almost a problem maybe unique to schools sometimes, because school starts, all these things happen during summer break. So you have all the school district trying to use this money, get things done before school starts again. So everyone orders the same equipment, the same people doing the installation. So there's a real rush to getting things done. And the school start next week. I think this was a picture taken by our field team. They were really just working 24 hours, just trying to get these things up. And they will make sure the heating and cooling is working, but the ventilation is the last part of it that if it doesn't get fixed and no one noticed, and they will just leave that part not done. This is one suggestion we have for the state. If this is required, someone's required to check these things are installed correctly in the classroom. There's definitely something that needs to be improved here to make sure that this is done according to what's the intention. Measuring airflow, it's time-consuming. So even the contractor on paper, I think they're required to do this step to check and verify, but clearly this was not done. And teachers are not able to detect the system. We asked all the teachers who participated in our study to fill out a survey, tell us what they think about indoor air quality, the ventilation system, and so on. We see no correlation between people who think the indoor air quality are good or bad with whether they have a system that's providing enough ventilation or not. The people are just not able to tell. And the last step of the way is that sometimes teachers work against the system. They think the system is too noisy. They don't understand that the fan is providing them with ventilation. They would turn it off. So the user aspect of it hasn't been quite thought out. Maybe there are systems that are a little bit quieter, but maybe when the person purchased it, that wasn't a factor. So we really recommend that when you think about the last person who's using it, in this case, a teacher, the noise is such an important factor in the school environment. So we really recommend that we think about that last part of it. Another problem that we've seen is in school, there's a lot of after-hours activity happening, and so it's hard to program a ventilation fan that can capture that part of it. A lot of times it operates from 7 to 3, and so after-hour activities would happen without any ventilation. That seems to be fairly common. Filters not getting changed, is still not getting changed. We heard a story where there's one person or two person responsible for changing filter for the whole school district. It's just a lack of resources to really get these things done. So some of the recommendations we are telling schools when we talk to school district is you can do a check. Probably the easiest thing to do is to buy a CO2 monitor, $200, I mean, sometimes less. If you see CO2 routinely above 1,000 ppm, every day of the week, all the time, that's a good signal that something's not right. It shouldn't be at this level. So that's a check that schools can do fairly easily. Switching to my last part of the talk was about homes. This is a project that sponsored by from the state of California to Department of Energy, and also we're working with our utility here in California. We did this study because homes in California now require mechanical ventilation. So we went to 70 homes that have mechanical ventilation and want to know what kind of mechanical ventilation system are installed. We recruit homes from Northern California and also Southern California. All these homes have a whole house ventilation system, also have bathroom fans and a range hood. Most of the times in California, it's an exhaust system, so it's an exhaust fan. A lot of times in a laundry room, a lot of times the laundry room have a jump duct to connect the air between the laundry room and the rest of the house. So that's a typical setup in California. We're now moving this project to other parts of the US and where we see more other type of system, like an ERV system or a supply system, sometimes called CFIS system, the central fan integrated system. So it's a damper that when your air handling works, it brings in outside air. So there's definitely a variation, but in California, by and large, it's an exhaust system. With the indoor air quality monitoring, the reason why the mechanical system requirement was put into our code was because we're building buildings to be more airtight. So the infiltration comes down, meaning we need more ventilation from outside to dilute the indoor air quality. So it's for an indoor air quality purpose, which is why we measure indoor air quality for this as part of this study. So we measure particles. It's still a concern in indoor, CO2, NO2, formaldehyde, and simultaneously we have a system outside that measure outdoor air quality. Obviously, that impact indoor air quality. We did a lot of diagnostic tests. So in each of the homes, we did a blower door test. We measured all the exhaust fan flow. For range hood, we used a duct blaster to help us measure the flow pulled by the range hood. We did activity monitoring. So a lot of what indoor air quality like depends on what people do in their home. So we measure how often they cook. Do they use the range hood? We're monitoring the clothes dryer as a big fan in people's home, and you use your clothes dryer, it pulls about 100 to 200 CFM over 1 whole hour, and depending how often you use it, so we will monitor that, and so on. We still do some survey and activity log to help us understand what kind of activities happen in the home. So here's the main finding. We find that most cases, the system put into homes in California did meet code. So that's good news. But only in 1 in 4 homes was the system operating. So builders put the system in, leave the people alone, and most people don't use it. Like, why don't people use it? So I mentioned that most often it's an exhaust system. It's basically just a switch. If I don't label that switch, you have no idea that controls something called a whole house ventilation system. You probably play with it and no lights turn on and you're like, oh, the switch didn't work. The code requires a label on the switch to tell user that this is for ventilation, you're supposed to use it. Unless there's a wildfire, then you're not supposed to use it. Or if you go on vacation for 7 days or more, then you can turn it off. So if that label's not there, which is in most of the cases, people just have no idea what this whole house ventilation system is about. Again, this is like the last step, putting the label on, but just that's just not done. So that's an indoor air quality study. How's indoor air quality? Indoor air quality is pretty good. So during that week, we told people that you have such a system. Can we operate it? They said yes, so we turn it on, and we measure indoor air quality. The Hinge 2016 to 18, so that's our study, the formaldehyde level, PM 2.5 level, and NO2 level. Compare that to what was measured about 10 years ago prior to this study in about the same types of homes, so new homes in California. We saw everything really came down. Why? We can look at it one by one. For formaldehyde, you have a slide on it. It has a lot to do with what California EPA pushed. This is the formaldehyde emission standard. So I think when it first pushed through, you can find products like when you buy from Crate and Barrels or IKEA, there's a label that say it passed the limit. So by asking a manufacturer to take out formaldehyde from the wood products, that really brings down the indoor formaldehyde levels, and that explained it. As to why PM 2.5 levels come down and NO2, it's comparable, but notice that the study that we did all used gas cooking. So we expect to see more NO2 when you cook. You use natural gas, that's a pollutant that we look for. And if you don't use a Rengie, we expect that number to be higher, but so that's very surprising. But PM 2.5, it may have something to do with we're now building homes to be quite tight compared to what was 10 years ago. We put in an exhaust system, so we're pulling air in through a building envelope that filters some particles. So that's like a passive system that is working for the lowering PM level in homes. We also see people using better filter compared to what it was from 10 years ago. These are generally MERV 8 filters. We saw some MERV 10, 11, 12 filters. So that may have a little bit to do with it. But runtime of the system is generally not very high in California. So probably it has more to do with the building envelope being better. So I mentioned the exhaust system and the slightly better filter may have contributed to a lower PM level in homes. We also see in some homes use air cleaners, so that could have some effect too. And so finally, I just want to mention some of the things that we're doing. The study we're doing right now, we're going to other parts of the US. So we are working with teams in Pacific Northwest, Colorado, Florida, very different mechanical system, different challenges, moisture being a challenge in Florida. If you bring in more outside air, what about moisture level in homes? So those issues, we're looking at those right now, and also in parts of other parts of the country where radon is still a problem. So parts of what we didn't quite look at is being investigated right now. Kitchen ventilation is an ongoing study. I show you pretty good numbers in new California homes, but that's all new homes in California, single family. So these are big houses in California. What we're doing right now is going to apartments. So we're building more multifamily homes. As you shrink the size, for apartments tend to be smaller, more people, indoor air quality, and also cooking emission really different. So we're doing a project looking at multifamily specifically. And Jeannie mentioned that the wildfire that we experienced, that's still an ongoing research that we're interested in looking at what other options people have. We also doing recommendations for clean air centers that will be getting set up in the Bay Area and elsewhere. So those are an active research area that we have. So thank you. Maybe I can answer a few questions. There's one in the back.
I noticed that on the residential study you did both indoor and outdoor sampling. Did you do outdoor sampling on the school study, and was it significant impact on the indoor CO2?
So outdoor levels, CO2 levels tend to vary between, I would say, 400, 500, sometimes occasionally getting 600 ppm. Indoor levels CO2 goes from 400 to 1,000, 2,000. So you just see the magnitude is, we're talking about apple and oranges here. So sure, it has a little bit effects. If CO2 outside is higher, there's no way to get indoor CO2 below the outdoor levels. But the variation is just not enough to cover what if you don't have enough ventilation, what's the ppm that we expect to see.
Any other questions?
More.
CO2 is just an indicator of lack of outdoor air. CO2 in and of itself is fairly, I guess what I'm saying is, I've actually seen situations building in really oddball places where the outdoor CO2 level could rise during the day higher than the indoor level.
Interesting.
I've seen
CO2 is an active area of research. So there are studies right now would study people performance tests that I mentioned before during those sim study tests. They hyperventilate the experimental space, but they inject CO2 to look at if CO2 is in effect a pollutant that would influence people work performance. Some studies show indeed an effect, so we're not talking about ventilation because the space is hyperventilated. So without injecting CO2, that space will have practically nothing. It's just clean air. But they inject CO2 and see if that people work performance are being affected. Some research have shown that there's an effect.
So in such a case where there's not much difference, does that mean that shouldn't stop you from not ventilating the building?
No,
the
that
mere
should.
existence of a slightly
Right.
higher level outside.
Right, I would
in
agree.
and of itself isn't a reason to not ventilate.
Yeah, in itself, yeah, I would agree. I would think you still should ventilate. One more?
Do you know what level of Park-Million are in this room right now?
Right now, it's pretty open door, 800? Is that a good guess? Oh, I'm guessing 800. Doesn't seem that high.
I don't have that app on my phone.
Sensors are getting a lot better. It used to be we really dealt all this. We've looked at long-term performance of the CO2 sensor used at DCV. Technology seems to have improved. In California, it's still only good for 5 years, so you should replace your CO2 sensor every 5 years. We've done a 2-year study in offices, classrooms. It seemed to last for the 2 years that we study, and it has improved. Prices are coming way down. There are some low-cost sensors that the sensor inside it costs only $10, $20, $30. But once they package everything, they sell it for you for a little bit more than that. But prices are coming down, accuracy improving. I think for CO2 sensor, we're looking really good. Maybe that's it. Great, thank you.
All right, so the last thing we want to do today, thank you, Rengie. The last thing we want to do is just kind of have a debrief on how the day went, especially the user or the activities that we had to do. So I'm seeing a thumbs up. What would you like to see in the future? What kind of things did you get out of it? What would you like to see more of in the future? Any other comments that you have about? Yeah.
I loved how on topic the presentations were with what we've been working on at this particular workshop. Very controls-oriented.
Controls-oriented presentations. You like that? Really good.
Feel free to break stuff again.
I'm sorry?
Feel free to break stuff again.
It feels break stuff in the building.
Like that.
Anyone else? Comments on, shall I get Chris back in here to hear some of this? Hang on.
A lot of the things that we've been coming up with during this institute had to deal with developing project-based learning exercises for students in varying programs. And one of the recurring things that came up with that discussion was the frustration level and how important it was for students to experience that. And it was on point to come in and have an exercise that gave us a good dose
Good. So if we did it right, we hope to have recorded at least one of those, maybe all three of those, so that you can then review them again too and get a sense of how the group progressed from frustration to cracking the egg to identifying something.
The recording didn't really work out that well. We maybe got one.
Okay.
I'll find out later.
All right. Well, we tried. We're learning new stuff, so next time, at least you experienced it and you know what happened. Peter.
So, was this more project-based learning or problem-based learning?
Problem.
Except that each group came up with different sets of solutions. So was it more open-ended than it appears to be?
Yes,
Yeah.
Yeah.
None of those solutions were incorrect.
None of the solutions you came up with were
That's important
incorrect.
piece of information too. None of those solutions were incorrect.
There was one,
That's
that
important to
questioned
know.
the value of.
I'm gonna give you the microphone.
Oh. I'm sorry, I wasn't actually gonna do that. The only one that I'm not really sure about is I actually checked the outside air damper and the dampers all work just fine. I physically checked those myself. Other than that, I would say that everything that was suggested by those three groups is accurate and correct and worth looking into.
One other question, this would be more of a capstone exercise in your program? Because it had so many elements, am I correct? You're doing it. Okay, so it's more. Integrated controls and data.
Right,
all of those
that
elements.
level.
It's a higher level.
Second year.
Okay, second year.
you can't just do this kind of thing once for the student and expect it to. I mean, this has got to be a way of life, you know, a teaching method that you use over and over again and make more complicated as they go. You can start these at a more rudimentary level or rudimentary system. By the time you get to one that's as complex as the one that we looked at today, yeah, that would be at a capstone level, I think.
But it also illustrates the need to bring in BAS even on the operations side. If you're teaching more on the operations side, you still need to be teaching BAS.
Peter, I've always expected that, and I hate to say it this way because I don't really want to rack and stack students, but the shining stars of go through the BAS program will probably end up in commissioning, working for BAS vendors, you know, and the other students may end up in, just working for HVAC contractors and building operations, but the fact they know BAS is just gonna make it easier for everyone in trade. Is that, being frank about it?
Well, I mean, now it's almost essential.
Yeah.
Don't we agree? Yeah.
I would say that in my experience on that, I feel that the big difference is between being very knowledgeable in individual pieces of equipment and being able to understand entire systems. And what you did today with the Sky Spark exercise was actually look at an entire system, which is not how we're usually trained. We're usually trained from the bottom up. You start with the thermostat, the sensors in the ceiling, we learn all those mechanical things, but we don't usually get that perspective where you can see everything that's going on. And I used to be a controls contractor. I used to do a lot of customer training. It's pretty rare that building operators really fully understand the complexity of a large variable air volume system, especially like we work with a lot of wet and dry labs, and they're a lot more complicated than a conference room. And I think that systems level knowledge is what I personally see is a lot of people are lacking that sort of education. Honestly, I'm not even sure where to get that education for our own staff without having to go through an entire program.
I would just like to point out that's the third day in a row of a so far our 3-day conference where system level thinking has come up as a hot topic area for us. Third day in a row, and most of the time it's come up more than once during the day.
But as you know, system level thinking is a great concept. It's really hard to do in practice. It's
Right.
a reminder to look bigger.
But exactly what we did today, Chris, is exactly what would happen to the guy the first time he's on call.
Exactly.
Something similar would happen, right?
Absolutely.
He's looking at,
Unless you're working on a brand new installation or you work in that same building every day, if you're a service technician, a lot of times you're walking in with no information. You're lucky. I don't know, did anybody notice that these VAVs, all these things have labels on them?
yes.
Says the
Oh,
VAV
yeah.
number, says the
Yeah,
room
we like
number.
to cheat ahead.
Ricky did that. I didn't ask him to do it. He did it probably a couple of years ago when he was trying to solve this problem previously. Because we have fixed this before. I know that air handler was working a year ago. But you know, you open up the control panels and you hope that somebody has some marked up notes in there that they left when they installed it. That's usually all you get, and you got to figure the rest out.
The wiring diagram with X's.
Mm-hmm. Yep.
Well, the one advantage you have in working in operations is at least you understand the building after a while.
Correct. Right. And you know, Ricky and Gonzalo have both been here for many years and know every single building on this campus, and that's a different perspective than a service technician who's riding around in a van every day.
And what we find here on this campus is some buildings were built for an entirely different purpose. The building that we're operating in was built as a lab, and then they broke it up into offices, and there's no end of ventilation problems with that. You're always fixing one place and then fixing another. But it's what happens, it's a practical reality.
Well, I hear all the time about the building that Janie's in, which is a building where we designed this entire HVAC system around an open office space, and then we put in a bunch of walls. Make it all a bunch of individual offices, but never touch any of the diffusers, never rezone anything, never move any of the thermostats.
Yeah, where did
I bet he's like that.
And we have one building on campus that not the one that we occupy, but one near our building, where we installed something that we thought was going to make the air handling units and the rooftop units operate more effectively. And just the fact that we touched those made people more sensitive to what was going on in the building, and we got a few more complaints about what was probably already the operating conditions.
You just put fake thermostats on the wall and that goes away.
Well, that was the problem. We replaced the thermostats that had the digital control, that had numerical control with heat versus cool, and we were real happy about that.
they never are.
All right, any other comments, questions? We have a little bit more for you today, yeah.
Well, I just wanted to say on this activity, what I appreciated was they could have fixed this whenever they came in and saw all the messed up stuff and just took the pictures, but they left it for us to
really
actually
hard for
it's
me.
really real time. So I'm sure it was hard for you guys to actually not just fix that and say we took some graphical stuff. You guys
Fortunately, it's only been a couple days that we've been looking at it, but it's been tough to not change
But like
it.
leaving it there where we can actually get into a real working system and actually look at real trend logs, it's not, you know, I don't know, I appreciated having the real data, real time that was actually happening, a real problem. So that was nice.
Pick the right building.